Hi Matt, gonna help you with this question. I've not seen it. I don't think. Where is it? Um, I think you're talking about question 21. I don't know if I'm wrong. Uh, so we're gonna say so. The question saying let f of this function. I don't know what to do. It's to make this a tablet. Okay, let's restart this. Sorry, give me 1 second. Um, to codomain is real. F of x. Oh, wait, what the heck? What is this? Okay, a nice problem. So it's saying let this function equal to this, and it wants us to find f dash one, which is just inverse. Okay, that's very easy. So it's saying when we trying to find the inverse, we can just flip x and y, right? So I'm gonna do that. X is equal to e to the y plus e to the negative y on 2. Right, happy with that? Just swapping x and y around. That's nothing too complicated. This is just good. Yeah, this is just to find the inverse here. And so what I'm gonna do is I'm gonna move 2x, make it 2x is equal to e to the y plus e to the negative y. That's all I'm doing. I'll just check if I copied the correct question. Yep. Okay. So here, what I'm gonna do is I have this function. I'm going to times everything by e to the y. EY is equal to EY times EY, that's our thing. First thing plus bracket EY times EY. Now, remember the power, not the power, the index rules that if we have the same base, then we can multiply it, and if it's multiplying, then we just say this is just 2y. Same with this, minus y plus y, EY is equal to e2y plus e0, because minus y plus y e0, and you know anything to the power of 0 is 1. Easy. Now right here I'm just going to move the negative 2 to this side by subtracting this. We're going to subtract it, so we get 2, sorry, hold on. We're going to get e2y minus 2x ey plus 1 equal to 0. Now, from here, we can see that this is a quadratic, right? You can see there's a 2 here, and if, for example, I can just show you that it's a quadratic, right? Pretend I let e to the y equal to a, right? That means I get a squared minus 2xa plus 1. And this is a quadratic, right? Can you see it? It's quadratic. If you want, what I can do here is just, simplify it into the quadratic formula. So x is equal to, oh, sorry. If I wanted to do this way, but I wouldn't do it this way. Honestly, I would. I'll rub it out. Can I rub it out? This stuff's so weird. Oh, there you go. It's this button. Ah, whatever. Ah, bro, what is happening, bro? I'm zooming in on nothing. Exit drawing. There you go. Sorry, Matt. Just still a bit used to this, right? I don't know what I've clicked on. Okay. Nope. I want to get out. Okay, so that's just to show you that it was a quadratic. Now I'm just going to say ey is equal to, I'm going to say minus b plus minus b squared for ac on 2a. That's a quadratic formula, right? For to find e to the y. And e to the y is equal to minus b. So, okay, let's just write that. A equal 1, b equal negative 2x, c equal 1. This is just for you to see that, this is b, this is a, which is 1, and then 1 times it, and it's just, just 1. So we're just going to say minus 2x plus minus 2x squared minus 4, 1, 1 on 2, 1, right, equal to minus 2x, you get 2x, plus minus 2x. If you square that, you get 4x squared. I don't know why it's going to change. 4 on 2. So then you get 2x plus minus. So I'm going to take out 4 here. Take out the 4. 1, 2. So close the bracket. Take out 4. Square root of 4 is 2. So 2x plus minus 2 x squared minus 1 on 2. And we can take out 2 here. I'm pretty sure you know how to do it, but I'll do it anyway. Boom, boom, gone. So we get the we haven't finished here because we're trying to find the inverse, right? And e to the y is not the inverse yet. We're nearly there. So, oh, sorry, I forgot to square these. I just realized. What we can do, how do we find, how do we get rid of this e? Well, if we take the natural log, so we take the natural log of e, we just get y, right? So we want to take the natural log, so y is equal to natural log x plus minus. Oh my god, I'm forgetting everything. Did I put plus minus up here? Sorry, it's plus minus, yeah. And yeah, that's it. So your inverse function should be equal to natural log x plus or minus x squared plus what? But minus what? But we have two functions here, right? Now, because domain is what's the domain again? I think it was 0 to infinity, because the domain 0 to infinity. As the domain is 0 to infinity, of f, domain of f, that means we have to, there has to be some, it has to be a positive, right? Because if you sketch this, like, logs always go this way, right? The natural log of anything goes this way. And if it was to be a negative, it would go another way, right? It may make sense. So our function has to be like this. Oh my god, I'm so ugly. Okay, so function then x plus minus x squared. But then we get rid of them things, so it's just plus. How do I work this out? Oh. I should never doing a video again. There you go. I don't know if that's the answer because this is like the hardest problem in the world. If I'm being real honest. Let me just upload this to YouTube. I can do that. Yep. Okay. Yep. Okay. Alright.